The air we breathe inside an airliner is continuously renewed during a flight. It's captured from outside. 30 to 50% of this fresh air, depending on the plane, is mixed with air already inside the cabin. Air from outside is collected near to the engines.
Boeing has done extensive modeling to understand the airflow in the cabin and the dispersion of particles. As part of that, we've done a comparison between the airflow in the airplane compared to an airflow in a stagnant air environment, which is the worst case for aerosol virus transmission.
Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. My name is Muhammad Haziq bin Abdul Halim, and today I am going to give you a presentation for my quick description about my assignment, which is the research proposal titled Modeling Airflow over Airplane by Computational Fluid Dynamics and Numerical Analysis. Right, I am going to look at 6 different aspects in today's presentation. The first one is abstract, introduction, literature review, research methodology, expected findings, and conclusions. Without further ado, let me start with the abstract. Airflow and pollutant movement inside aeroplane cabins are important for creating a comfortable and clean environment. This proposal wants to describe the findings of a research into airflow and pollutant transfer in a half-filled twin aisle cabin mock-up. The numerical conclusion matched the experimental data. However, airflow distribution was inconsistent. Computer models and experimental measurements were both maybe inaccurate. Secondly, for the introduction. The recent years, we have been seeing a tremendous increase in the number of persons traveling by commercial airplanes. These passengers are subjected to low air pressure, low humidity, and air contaminants such as airborne microorganisms that cause disease and infections. When an aeroplane is traveling at higher altitudes, the inside is exposed to some dangerously high temperatures and pressures. Increasing air travel, high passenger density, and the inability to leave the aircraft while at whim, and a long-haul route flight requires a strict control of the temperature, carbon dioxide levels, air velocity distribution, and contamination. Experimental and numerical research have been undertaken on airplanes cabins and ventilation systems. Experiments can be done on a static aeroplanes or a mock-up cabin. Computational fluid dynamics calculates airflow distribution for numerical investigation. It is customary to study both experimental and computational fluid dynamic techniques simultaneously to compare and assess the data. Up to the next one, the literature review. From the first source, a computer CPU is cooled by the heatsink with fins and fans. Impinging flow and parallel flow are the two most common airflow layouts. Analytical, numerical, and semi-empirical models accurately predict the heatsink performance. This research compares and contrasts the recent and typical models for both flow configuration. The study examined models that predict pressure drop and thermal resistance for dark flow and impinging flow heatsinks. In the second sources, cooling and storing agricultural commodities involve both heat and mass, and due to uneven airflow, industrial cooling rooms struggle to chill and store fresh goods uniformly. According to Nahor et L, the variable cooling pace and the product temperature inside a cool store causes product quality to deteriorate through enhanced respiration at higher temperatures or chilling, freezing harm at lower temperatures. Airflow over airplane uses similar ideas. The distribution systems on a modern aircraft provides significantly enhanced protection against airborne pathogens compared to the most other typical environment. But its design was primarily driven by the desire to make passengers and crew as comfortable as possible, while also meeting the cooling requirements of the aircraft electronic systems. For the next part is the research methodology. Expensive, time-consuming experiments are the best way or approach to determine how air behaves in a room. CFD is significantly cheaper depending on the approach and the geometry employed, and can be forecast the airflow structure better than the actual observation. Computational fluid dynamic results can be inaccurate if the starting values, boundary conditions, and the grid quality are ignored. And also, using a transient two-phase model of a heat and mass transfer in a cool store was proposed. Expected findings. In the simulation of computational fluid dynamics, the observed boundary condition were used, and this was done in combination with the numerical technique that was explained in the previous section. Following that, the result from computational fluid dynamics were compared to the information gleaned from the experiment. Even though there are still some strange things going on, the computational fluid dynamic is able to accurately show how the flow works in the middle plane. The study shows that a cabin atmosphere is comparable to a building's because both are enclosed and have ventilation systems. The integrated computational fluid dynamic tool presented in the paper for modeling airflow and pollutant transport has the potential to be employed in the building environments provided proper validations will be performed. For the last one, which is the conclusion, in order to figure out how air moves around bin, a simplified model for two-phase momentum, heat and mass transfer in a cool store that is both empty and full of agricultural product was made. Things that we can relate to another one. Computational fluid dynamic can be used to measure and simulate both the flow of air and the movement of pollutants inside a cabin where people are present. The goal of the research was to determine on how contaminants move throughout the air. The sub-micron size heavy particles move through the cabin the same way the passive gas pollutant did, with the exception of the area to the next source where they move much more slowly in the rest of the cabin. The study also looked at how gases and particle contaminants are moved around and spread, and it found that there are more similarities between the two than there are differences. I think that's all from me. My name is Muhammad Haziq bin Abdul Halim, and that is my research proposal. Assalamualaikum, thank you.